So today we're going to be talking about the inside-outside rule. Okay, so the inside-outside rule is just a shortcut for chain rule. Okay, so instead of taking a function and splitting it up into multiple pieces and moving it through that way, doing chain rules, picking u and then y is in terms of u, we have a shortcut that we call the inside-outside rule. So if we were doing this one, basically we'd have to say u is x squared plus 4. And then we say y equals e to the u. Okay? And then we'd say dy over du is e to the u. And then du over dx is 2x. And then we multiply those two things. And we get e to the x squared plus 4 times 2x. And that's our derivative, doing it explicit chain rule style. Okay? But now we're going to use a shortcut. Okay? We're going to do inside-outside. So we start off basically with the same function. But now what we're going to do is we're going to take the derivative of the insidemost function and work our way out from the center. Okay? So basically my inside function is my x squared plus 4. Okay? So we take the derivative of my inside. So y prime equals 2x. So that's my inside function. Times the derivative of my next function, which is e, right? What's the derivative of e? E to the x, right? So I take the derivative of the outside function, but I don't take the derivative of the inside function. So basically, when we do it chain rule style with explicit u and splitting it into y and u, we're taking the derivative of each function just one time. Inside-outside, same thing. We're taking the derivative of each one time. So when we take the derivative of this x squared plus 4 right here to get 2x, when we take the derivative of our next function, whatever is inside stays the same. We don't take the derivative of it twice. Just like with product rule or quotient rule, we take the derivative of each function just one time. Okay? But this is the inside-outside rule. Now notice the difference is just going to be the ordering. So if explicitly, we end up with the inside function at the end, but when we do inside-outside, we end up with the inside function first. Okay? So let's look at the next one. And I'll erase this a little bit because it's covering. So this one. Again, we've done this one chain rule explicitly, but now we're going to do inside-outside rule. So we start with the inside function, which is 6x cubed. The derivative of 6x cubed is 18x squared times the derivative of the outside function, and the derivative of cosine is negative sine 6x cubed. And that's the derivative. So basically, the inside-outside rule is a way of doing chain rule faster. It's just a shortcut. We're getting the same answers, but in the reverse order. Okay? And remember, we only take the derivative of each term or each function one time. So when I go to take the derivative of the outside function, the inside stays the same. Okay? It also makes problems like this, where we're doing multiple rules at one time, a lot simpler. Because to take the derivative of this one, we have a product rule going on. So we'd find the derivative of our first function, which is derivative of x is 1, times the natural log of 2x, plus x times, and now the derivative of ln of 2x, we would have to normally do chain rule, but now we have the inside-outside rule. The derivative of 2x is 2 times the derivative of the natural log of 2x, which is going to be 1 over 2x. and then we simplify. And again, if we simplify, you see that we get the same thing we did when we do chain rule explicitly. And the 2x goes to the top, and you get 2x over 2x, which is just 1. Okay. And then again, the last one, same thing, makes our lives a whole lot easier because we have product rule again. So the derivative first is 2x times e to the pi x plus x squared. And now we have to do chain rule, but we don't have to do it explicitly anymore. So the derivative of pi x is pi times e to the pi x. And again, all we're doing is we're doing the same thing we did before, but we're just doing it in a shortcut method. We're taking the derivative of each function, the inside to the outside, but we're not explicitly saying, okay, this is my u, this is my y in terms of u, but you've got to think about that still. But it should work out just fine. And that's the inside-outside rule.